In this session, we will learn how to define functions to reuse blocks of code and use modules to write well-structured and modular programs. Functions are used to break down code into smaller units and make programs more readable. It can take values as arguments and return values as output. A function is created using the def keyword, followed by the function name and an argument list, which can be empty. Since functions introduce a new block of code, function definitions are terminated with a colon. The function body is the indented block which follows the def keyword. Here we define a function named sum with two arguments a and b. The sum function adds the two values and returns the result as output. Functions require data in the form of arguments which are passed from the calling program. Python allows functions with keyword arguments where name of the arguments are treated as keywords and matched in the function definition. This way we can pass the arguments in random order to the function. For example, a function defined with arguments as name and message is called by the calling program. In the calling method, we see that arguments are given specific values and the function is called. This allows the function to match with the arguments with the incoming values. Now we have seen how simple function works. It takes arguments and returns the output. Here the sum function takes two arguments and returns the sum. Here, while calling the function, we assign value to arguments and treat the argument name as keyword. This way, arguments are matched in the function call. To use default values of arguments, we assign values to arguments in the function definition. While calling the function, we can specify the new value of argument with default value, or we can skip the argument in the function call. Lastly, for a function with variable arguments, we call the function with required number of arguments separated by comma. In the output, we see that the argument type is a tuple, and we can access the arguments from the tuple. Another important aspect of functions is to understand the scope of variables used in the function being called. Variables defined inside the function are local to that function and termed as local variables. Let us see how local and global variables are defined in the program. Here we have a function named calculate with variable arguments. We have defined a variable sum both inside and outside of the function and assigned a value of 0 to it. We call the function with the arguments and get the sum of the arguments. In the output we see that the sum variable outside the function is still 0. This means that the sum variable inside the function is only modified and sum variable outside the function is not altered. In the second function, we define some variable outside the function and use global keyword for some variable inside the function. This way we are accessing the sum variable defined outside the function from within the function using global keyword. In the output we see that some variable is having a value of 60. So variables defined inside the function have a local scope and cannot exist outside the function, whereas variable defined by global keyword will modify the variables defined outside the function, which have a global scope. Now let us move on to modules in Python. Module provides us the flexibility to organize the code in a logical way. It can contain any code which we want to reuse in our program multiple times. It can contain class definitions, functions, or global variables. We need to use import keyword to import the external modules in the main program. Let us understand use of module in an example. We define three functions and save it in a script file called calculate. Now in another script file, we import the calculate module using import keyword. Cal is used as name for the calculate module. Using cal object, we access the methods in the calculate module. This way, script files can be used as modules in different script files and make programs modular.